Welcome to this video on transformations of exponential functions. By the end of this video, you should be able to compare exponential function graphs using Desmos, determine the transformation of an exponential function given a graph, determine the transformation of an exponential function given its equation, and write exponential functions with transformations. So you should take this time to go through this discovery activity and answer the questions. In set 1, you'll put all of these equations in, and you want to see how these 2 through 5 compared with the first equation, and then answer the question. Erase all of those equations and start again with set 2. How do 2 through 5 compare to 1? What happens when you manipulate the equation? Answer the questions. And again for set 3, once you've done that, come back for the notes. So hopefully you did the transformation discovery on the previous page. We're going to be looking at the exponential equation. This is what we have been looking at, y equals a times b to the x. But we saw in the discovery, if you have something else in the exponent besides just the x, the graph will move in a particular way. And if you have a number added or subtracted to the end, it's also going to move the graph in a particular way. All right, so let's take a look. The h value. The h value is up here in your exponent, okay? If the exponent says x minus h, then your graph is going to move to the right. Because this is a negative sign in your exponent, to have x minus h, it'd be x minus a positive number, and that positive number would mean you would move to the right. If it says x plus h, that means you would have had x minus a negative number, and so that's going to move your equation to the left. Okay. The k value, the number that's added or subtracted out here on the end, we've actually talked about already. That's your asymptote. So if your k value is positive, it's going to move the graph up. If your k value is negative, it's going to move your graph down. K is the asymptote, and so we've been writing the equation y equals whatever the number is, so y equals whatever k is. All right, so let's take a look. We're going to list all the transformations from the parent function. So this is the parent function. All other equations are born from this one. And we want to see how each of these compare to this equation. Okay, so this says f of x equals 2 to the x minus 5. We have a minus 5 on the end, so that means the whole graph will move down 5. Okay. Compared to the parent graph, we have x plus 1. Remember, if it says x plus, it's actually moving to the left. So this is going to move left 1. And then the minus 2 on the end says it's going to go down 2. Okay. In C, there's nothing happening up in the exponent, so there's no left or right movement. We just have a minus 3 on the end, so that's down 3. And then our last one, in the exponent we say minus 5. Remember, if it's minus, it moves right. So this says we're going to move right 5, and the plus 3 means we're going to move up 3. All right. So let's try it with something other than the parent function. So this is how you can see it in a question. They'll give you an equation and then say what transformation is occurring in this equation compared to the last one. So you just want to go back and look that they're different. So nothing is happening in the exponent, so there's no left or right movement, but there's a plus 8 on the end, so that whole graph is going to move up 8. In question 2, here's our original equation. This is our transformed equation. The only difference between these is in our exponent. It says x plus 7. Remember, plus means move left, so we're going to move left 7. Nothing else will change about that graph. Okay, in number 3, we're back to the regular parent graph. Now, this is the original graph. How is this one transformed from the original? In the exponent, we say x minus 3. So that actually means right 3. And then it says plus 2, so that's up 2. Okay, so you're just looking at the exponent and what's going on in the end to see what kind of left and right transformations and up and down transformations we're looking for. How did the graph move on the coordinate plane? For this last one, we're going to work backwards. I want you to write the equations with particular transformations to them. So we're going to start with the parent graph. That's the one they want us to transform. So that's what it looks like right now. And this says to shift left 7. So if I want to move left, I have to say x plus the number. Okay, so I already have the x. If I want to go left 7, I have to say plus 7, and that will show a left shift. Let's try it again for number 6. We'll have f of x equals, this is what we're transforming. This says shift right. Well, if left was positive, right is negative. Right 5. And then down 3, down is off the end, up and down is off the end. That's a minus 3 on the end. Now reflect, we didn't have that happen, but on the discovery, if there's a negative sign in front, then you have a reflection, and here's what I mean. So here's our original. Okay, reflection, you got to put a negative sign in the front. And then down 3 is not in the exponent, it's off the end, so that'd be minus 3. Okay, and this last one has everything going on, so let's see. Let's put our basic equation. This is what it asked us to start with. Okay, and so if we have a reflection, that means put a minus sign in the front. Left 4 is in the exponent, we'd write plus 4, and up 9 is off the end, and we'd write plus 9. Hopefully that was helpful. Let me know if you have any questions. See you in class.